Jai Shri Gurudev. Good morning to everyone student. Welcome to chemistry class. In our previous classes, we learned about the modern periodic table and the classification of elements into different blocks, that is S block, P block, D block and F block, and their respective outermost and valence shell electronic configuration. Okay, that is called as classification of elements. Okay, in our chapter we have learned already classification of elements. Now we are moving to study about periodicity in properties. That is periodicity in properties. It means the periodic properties of an element. Okay, you know the elements are classified into S, P, D and F block elements. Now we are learning what are the properties of those block elements. Okay, that is there are some common properties. Those we are studied under the periodic properties of an elements. Now the first one is atomic radius. Atomic radius, or we also called as atomic radius. You know the concept of an atom well. The atom consists of the central proton nucleus. That nucleus having protons and neutrons. Protons and neutrons. Okay, this is called as a nucleus core present in an atom. Around the nucleus there is a circular orbits like that. These are the circular orbits, and we also called as shells. That is K, L, M, N, so on, like that. We are called shells. This is the main structure of an atom, and these shells contain electrons. Like these electrons are revolving around the nucleus. Okay, like that the electrons are revolving. This is the structure of an atom. Here, the atomic radius is defined as the radius of a nucleus of an atom to the outermost shell of an electron. Atomic radius is defined as the radius of the nucleus of an atom, that is center of the nucleus of an atom, to the outermost shell of an electron. This is called as atomic radius. Okay, so atomic radius ಅನ್ನೋದು ಏನಂದ್ರೆ ಒಂದು ಆಟಮ್ ನ ಒಳಗಡೆ ನ್ಯೂಕ್ಲಿಯಸ್ ನ ಸೆಂಟರ್ ಇಂದ ಹಿಡಿದು ಔಟರ್ಮೋಸ್ಟ್ ಶೆಲ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ. ಔಟರ್ಮೋಸ್ಟ್ ಶೆಲ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ. ಆ ಶೆಲ್ ವರೆಗೂ ಇರುವಂತ ಡಿಸ್ಟೆನ್ಸ್ ಅನ್ನು ಏನಂತ ಕರೀತೀವಿ ಅಂದ್ರೆ atomic radius. Okay, atomic radius is the distance between the nuclei of an, that is center of the nucleus, to the outermost shell of an electron. Is called as atomic radius or atomic radius. Now this atomic radius is not a constant. It will be changes from place to place. It means it depends on the environment because the outermost shell of an electron is reacts with another atom, means neighboring atom. Therefore it form molecules or a compound. During that stage the atomic radius is varies. It means either it may be shrunken, means decrease or go to, or it may be increases, means larger. So that the atomic radii is the further having 4 different types. Those are covalent radii or covalent radius. Then second one is metallic radius. Then third one is Vander Waals radius. Vander Waals radius, and the last one is ionic radius. So ಏನು ಮಾಡ್ತಾ ಇದೀನಿ ಅಂದ್ರೆ ಈ ionic radius ಅನ್ನೋದು ಫಿಕ್ಸ್ಡ್ ಆಗಿರೋದಿಲ್ಲ, ಚೇಂಜ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಯಾವ್ದ್ರ ಮೇಲೆ ಅಂದ್ರೆ ಅಥವಾ ಎನ್ವಿರಾನ್ಮೆಂಟ್ ಮೇಲೆ ಚೇಂಜ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಯಾಕೆ ಎನ್ವಿರಾನ್ಮೆಂಟ್ ಮೇಲೆ ಚೇಂಜ್ ಆಗ್ತಾ ಇರುತ್ತೆ ಅಂದ್ರೆ ಒಂದು ಆಟಮ್ ನಲ್ಲಿ ಇರುವಂತಹ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅದರ ಪಕ್ಕದಲ್ಲಿ ನೈಬರಿಂಗ್ ಇರುವಂತಹ ಆಟಮ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗಿಬಿಟ್ಟು ಬಾಂಡ್ ಆಗ್ತಾ ಇರುತ್ತೆ, ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಫಾರ್ಮ್ ಆಗ್ತಾ ಇರುತ್ತೆ, ಇಲ್ಲ ಕಾಂಪೌಂಡ್ಸ್ ಫಾರ್ಮ್ ಆಗ್ತಾ ಇರುತ್ತೆ. Therefore ಅದರಿಂದ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಅಟಾಮಿಕ್ ರೇಡಿಯಸ್ ಅನ್ನೋದು ಚೇಂಜ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಆ ಚೇಂಜ್ ಆಗ್ತಿರೋ ಕಾನ್ಸೆಪ್ಟ್ ಬೇಸಿಸ್ ಮೇಲೆ ನಾವು ಮತ್ತೆ 4 types ಆಗಿ ಸ್ಟಡಿ ಮಾಡಬೇಕಾಗಿರುತ್ತೆ. ionic radius, atomic radius can be studied further 4 types, that is covalent radius, metallic radius and Vander Waals radius, then ionic radius. Now take first one, covalent radius. Now take the first one is covalent radius. This covalent radius is defined as one half of the distance between the nuclei of two covalently bonded atoms and these atoms of the same element in a molecule is called as a covalent radius, that is indicated by RC. So here is one half of the distance between two covalently bonded atoms of the same element in a molecule. Same element is nothing but it consists of same kind of atoms. Okay, molecule consists of many number of elements, that is called as meaning of a molecule and elements. Now for example, see, take example hydrogen molecule, it containing 2 hydrogen atoms. Okay, 2 hydrogen atoms, these two are covalently bonded. This is called as an element, or we call it as a molecule, hydrogen molecule. Here H is an element. Now here the hydrogen molecule covalent radius is 74 picometer. The covalent radius of hydrogen molecule is 74 picometer. Like as you know, this is a hydrogen molecule. This is one hydrogen molecule, means hydrogen atom, and this is second hydrogen atom. This is first hydrogen atom, center of the nucleus. This is the center of the nucleus. So it is nucleus the center ಆಗಿರುತ್ತೆ, means atom the center ಆಗಿರುತ್ತೆ. ಇಲ್ಲಿ covalent radius ಅನ್ನೋದು ಎರಡು atoms close ಆಗಿರುತ್ತೆ. Okay, this is called as a covalent radius, means the radius. This whole thing is not covalent radius. This is the radius of these two atoms. This is one atom radius, this is one hydrogen, another hydrogen atom radius. This is one hydrogen, this is another hydrogen. These two make a bond like that. Hydrogen molecule. Now here according to definition, one half of the distance. This is one in the half. This is the half of the distance. One half of the distance. This is called as covalent radius. Covalent radius, that is radius R, and this is the covalent. This is the one half of the distance between the covalent radius in a hydrogen molecule of two covalently bonded atoms of a same molecule in an element. Now here, this is whole thing we call as common 74 picometer. This is 74 picometers. Now the covalent radius is the half of this 74. Okay, let's assume this is the R1 and this is the R2 distance. Or this is also take a R1. Okay, let's assume this is one atom, this is 2 atoms, therefore 2 R2. So R1 plus R2 is equal to how much? 74 picometer. Okay, therefore R1 plus R2, those two becomes 2R1, that is equal to 74 picometer. Because the R1 is same as that of the R2, right? Here we can write if R1 is equal to R2. If R1 is equal to R2, here both are same. Therefore, 2R1 is equal to 74 picometer. Then R1 is equal to 74 divided by 2 picometer. That is R1 is equal to how much is it? 74 divided by 2, 37. Okay, here the covalent radius of hydrogen molecule. Covalent radius of a hydrogen molecule is how much? 37 picometer. Okay, like that. Similarly, take a chlorine molecule. The chlorine molecule atomic radius is 228 picometer. The covalent radius of a chlorine molecule is 228 picometer. Let us assume now this is one chlorine molecule Cl and this is one chlorine molecule. Now between these two, the distance is 228 picometer. That is 228 picometer. Now the covalent radius is nothing but 228 divided by 2. That is 228 divided by 2. How much you get? 116 picometer. Okay, 2 ones are 2 ones are 2 ones are 2 fours. That is 114 picometer. Okay, that is the covalent radius. That is 114 picometer. chlorine molecule. Covalent radii is 114 picometer. So this is the not a chlorine, this is bromine molecule. This is the bromine. Bromine is 228, its covalent radii is 114. Similarly, let's take a chlorine. The chlorine atomic radii is, similarly take a chlorine. The chlorine molecule atomic radii is 198 picometer. 198 picometer. Let us say this is one chlorine molecule. And this is one chlorine atom. The covalent radii of these two chlorine molecules is how much? 198 picometer. Therefore, the covalent radius of each atom, one atom covalent radius estirutte 198 divided by 2 like that. Okay, 198 divided by 2. ಎಷ್ಟು ಬರುತ್ತೆ 2 1s 2 9s and 89 2 9s that is 99 picometer ಬರುತ್ತಲ್ವಾ. ಸೊ ಒಂದು ಕೋವಲೆಂಟ್ ರೇಡಿಯಸ್ ಕ್ಲೋರಿನ್ ಮಾಲಿಕ್ಯೂಲ್ ಇಷ್ಟಿದೆ, ಕ್ಲೋರಿನ್ ಆಟಮ್ ಎಷ್ಟಿರುತ್ತೆ 99 picometer. Okay, this is chlorine molecule 74 is the chlorine atom is 37 picometer. Similarly, now observe here, you know the hydrogen molecule atomic radii and atom atomic radii, covalent chlorine molecule covalent atomic radii ಎರಡು ಗೊತ್ತಾಯಿತು, chlorine ಗೊತ್ತಾಯಿತು, hydrogen ಗೊತ್ತಾಯಿತು. Now by using these two you can find the hydrogen chloride HCl. HCl ನ molecule atomic radii ಅಥವಾ covalent radii ಅನ್ನು find out ಮಾಡಬಹುದಲ್ವಾ. hydrogen ಗೊತ್ತಿದೆ, chlorine ಗೊತ್ತಿದೆ. Now let's assume this is one hydrogen molecule. Now observe, let's assume this is hydrogen. Here for chlorine molecule you know 99 picometer, for hydrogen you know 37 picometer. Let's assume to form HCl. HCl ಅನ್ನೋದು covalent compound form ಆಗಬೇಕಾದ್ರೆ H ಅನ್ನೋದು atomic number 1, chlorine 35. ಇದು ದೊಡ್ಡದು ಇದು ಚಿಕ್ಕದು. Okay, so write this is the hydrogen atom and this is the chlorine. Alva, one is hydrogen, this is chlorine. At the center of the nucleus and here the chlorine nucleus center. This is called as what? Covalent radii. Where to covalent radii irutte adella half tagobeku andre ಎಷ್ಟು ಇರುತ್ತೆ ನೋಡಿ. ಹೈಡ್ರೋಜನ್ ಎಷ್ಟು 37, ಕ್ಲೋರಿನ್ ಎಷ್ಟು 199. So ಎರಡನೇ ಸಮ ಮಾಡಿದ್ರೆ ಎಷ್ಟು ಬರುತ್ತೆ 99 plus 37. So that is equal to how much? 1 ತಗೊಂಡ್ರೆ 10 plus 6 1 plus 10 plus 3 30 136 picometer. Okay, this is the covalent radii of HCl. Okay, now from all these things, this is 37 picometer, this is 99 picometer. From here to here, this whole distance is how much you get? 136 picometer. This is called internuclear distance. This is called as what? Internuclear distance. Internuclear distance. So from this covalent radii we know when they given internuclear distance of the two atoms or molecule, you can find the covalent radii of an atom, or also you can find another molecule or atom covalent radii. And the total internuclear distance ಅನ್ನೋದು ಕೊಟ್ಟಿದ್ರೆ ನಾವು covalent radius ಅನ್ನು find out ಮಾಡ್ಕೋಬಹುದು. ಯಾವುದು ಒಂದು atom ಒಂದು known ಆಗಿದೆ, ಒಂದು ಗೊತ್ತಿತ್ತು ಇನ್ನೊಂದು ಗೊತ್ತಿಲ್ಲ ಅಂತ find out ಮಾಡ್ಕೋಬಹುದು. ಅಥವಾ ಎರಡು ಕೊಟ್ಟಿದ್ರೆ ಟೋಟಲ್ ಇಂಟರ್ನ್ಯೂಕ್ಲಿಯರ್ ಡಿಸ್ಟೆನ್ಸ್ ಅನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬಹುದು. ಓಕೆ, ಈ ರೀತಿ ಆಗೋದ್ರಿಂದ ಅಟಾಮಿಕ್ ರೇಡಿಯಸ್ ಅನ್ನೋದು ಚೇಂಜ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಸೊ ದಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಟಡಿ ದಿ ಕೋವಲೆಂಟ್ ರೇಡಿಯಸ್. ಓಕೆ, ಐ ಹೋಪ್ ಯು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ದೆನ್ ಟೇಕ್ ನೆಕ್ಸ್ಟ್ ಒನ್ ಮೆಟಾಲಿಕ್ ರೇಡಿಯಸ್. The next one is metallic radii. So listen here, most of the compounds or elements do not form covalent compound. Means most of the metals, when we are taking d block elements like iron, copper, nickel, palladium, platinum, all these are the metals. Such kind of elements do not form covalent compound. However, they form metallic compound, so that you get a concept to define metallic radii. Okay, so that the metallic radii is defined as one half of the distance between the two nuclei, distance between the nuclei of two atoms in a metallic crystal. Metallic crystal is called as a metallic radii. So ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ ಒಂದು metallic crystal ಅನ್ನು ತಗೋಬೇಕು. Let us assume this is a metallic. crystal. Here there is so many atoms which are bonded metallically. The metallic bond ಆಗಿ bond ಆಗಿರುತ್ತೆ. ಇಲ್ಲಿ ನಾವು covalent bond ಅನ್ನು ನೋಡಕ್ಕೆ ಆಗೋದಿಲ್ಲ. ಈ ತರ ಮೆಟಲ್ಸ್ ಅನ್ನೋದು ಏನಾಗುತ್ತೆ ಒಂದು ಕ್ರಿಸ್ಟಲ್ ಲ್ಯಾಟಿಸ್ ಅನ್ನು ತಗೊಂಡಾಗ this is crystal lattice. This is crystal lattice. In this crystal lattice, see these metals are metallically bonded. ಅಂದ್ರೆ metal bond ಆಗಿರುತ್ತೆ, covalent bond ಆಗಿರೋದಿಲ್ಲ metals ಅಲ್ಲಿ. Therefore, the metallic radius is defined as one half of. Let's assume this is the two metal atoms. The center of the two metal atoms, this is called as internuclear distance. Internuclear distance. In a crystal lattice, two atoms. ಎರಡು atoms ಮಧ್ಯೆ ಒಂದು crystal lattice ಅಲ್ಲಿ ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಇದೆಯೋ internuclear distance ಅದನ್ನ internuclear distance ಅಂತ ಕರೀತೀವಿ. So here one half of the distance between the nuclei of two atoms in a metallic crystal. In this metallic crystal, one half of the distance between nuclei of two metallic atoms is called as a metallic radius. For example, take a copper. The copper internuclear distance between the two atoms in a metallic crystal is given by 256 picometer. Is found 256 picometer. ಅಂದ್ರೆ copper ಅಲ್ಲಿ let us assume this is copper crystal lattice. ಈ copper ಅಲ್ಲಿ ಎರಡು atoms ತಗೊಂಡಿದ್ದೀವಿ. These two atoms, these two are metallically bonded. The center of the nucleus of these two atoms is called as internuclear distance. The internuclear distance is 256 picometer. Okay. Therefore, the metallic radius is equal to 256 divided by 2. 256 divided by 2 because half of the distance, right? This is total distance, internuclear distance. Half is nothing but divided by 2. That is how much you get? 128 picometer. This is the metallic radius which is found only in metallic crystals. Okay. Then take next one, Vander Waals radius. The third one is a Vander Waals radius. This Vander Waals radius is defined as one half of the distance between the nuclei of two adjacent atoms. Nuclei of two adjacent atoms belonging to the two neighboring molecules of an element in a solid state. This is called as Vander Waals radius. See here, this Vander Waals radius is a type of hydrogen bond. Like assume to understand the Vander Waals radius concept, it is one half of the distance between nuclei of two adjacent atoms. Let's take two adjacent atoms. This is the one atom which is bonded to the another adjacent atom. Two atoms which are bonded each other, neighboring atoms, that is adjacent atoms, these two, which is belonging to the two neighboring molecules. Let us say this is one molecule. Okay, molecule means two atoms are bonded. Now adjacent molecule, let's take another one, adjacent molecule. This is one molecule and another one. These two are bonded together. This is another one. This is one molecule, this is one more molecule. Now the distance between the center of the nucleus, one half of the distance between the nuclei, right? This is the center of the nucleus for this atom, this is second atom, this is center of the nucleus. Now for this one atom center of the nucleus, this is for another atom. Now this is one molecule, this is one molecule. That is adjacent belonging to the two neighboring molecules. We are taking two neighboring molecules. These two center of the nucleus is this one. This distance is called as what? Internuclear distance. Internuclear distance. And then nucleus na madhya iruವಂತ distance is called as internuclear distance. That is distance between two nuclei of two different atoms or molecules, same atoms or molecules, we called as internuclear distance. Here, this internuclear distance at the center is this one. Now draw a line like that, and here. This distance from here to here, this is called as Vander Waals radius. called Vander Waals radius. This is seen only in a solid state of a two neighboring molecule which are bounded which are adjacent to the two atoms in a molecule. Okay, ಒಂದು molecule ಅಲ್ಲಿ ಎರಡು atoms ಒಂದಕ್ಕೊಂದು adjacent ಆಗಿ ಪಕ್ಕದಲ್ಲಿ ಇದ್ದಾಗ ಮಾತ್ರ ನಾವು Vander Waals radius ಅನ್ನು ನೋಡೋಕ್ಕಾಗೋದು. Okay, this is the concept of Vander Waals radius. Now for example, take a hydrogen molecule. This is one hydrogen molecule H2. Okay, one hydrogen, one more hydrogen. This is similarly hydrogen and hydrogen, two hydrogen. Second bond ಆಗಿದೆ hydrogen molecule ಬಂತು. So ಈ ಎರಡು ಮಾಲಿಕ್ಯೂಲ್ ಮಧ್ಯೆ ಒಂದು ಮಾಲಿಕ್ಯೂಲ್ ಅಲ್ಲಿ ಇರುವಂತಹ ಆಟಮ್ ಇನ್ನೊಂದು ಮಾಲಿಕ್ಯೂಲ್ ಅಲ್ಲಿ ಇರುವಂತಹ ಆಟಮ್ ಎರಡರ ಮಧ್ಯೆ ಇಂಟರ್ನ್ಯೂಕ್ಲಿಯರ್ ಡಿಸ್ಟೆನ್ಸ್ 240 ಪಿಕೋಮೀಟರ್. ಎರಡು ಆಟಮ್ಸ್ ಮಧ್ಯೆ 240 ಪಿಕೋಮೀಟರ್ ಇದೆ. ನಾವು ಹಾಫ್ ಆಫ್ ದಿ ಡಿಸ್ಟೆನ್ಸ್ ಅಂದ್ರೆ 240 ಡಿವೈಡ್ ಬೈ 2 ಮಾಡಿದ್ರೆ ಎಷ್ಟು ಬರುತ್ತೆ? ಹೈಡ್ರೋಜನ್, ದಟ್ ಇಸ್ 120 ಪಿಕೋಮೀಟರ್. This 120 picometer is called as Vander Waals radius. Okay, Vander Waals radius and this is Vander Waals radius. Vander Waals radius. Okay, I hope you understand. Vander Waals radius is the one of the distance between nuclei of two adjacent atoms belonging to the two neighboring molecules. It's called as atomic, it's called as Vander Waals radius in a solid state. This is seen only in solid state. Okay. Now take third one, ionic radius. Fourth one, ionic radius. The fourth one is the last one, that is ionic radius. This ionic radius is seen only in the ionic compounds or in ions only. Ions are not an ionic radius defined ಮಾಡಬಹುದು. So here ionic radius is defined as the distance between the nucleus of an ion and a point up to which the nucleus has influence on its electron cloud is called as ionic radius. So ಈ ionic radius ಏನೊಂದು ionic compounds ಅಥವಾ ions ಅನ್ನು ಮಾತ್ರ ನೋಡಬಹುದು. ಇಲ್ಲಿ ಏನು ಹೇಳ್ತಿದೀವಿ ಅಂದ್ರೆ for example see, this is an atom. Inside an atom there is a nucleus. This nucleus contains what? Protons and neutrons. Around that there is an orbitals. These orbitals contain what? Electrons like that. Okay, now this electron cloud, let's assume this is an ion. In the ion, the charge of the nucleus will be remain same. Therefore, the neutrality of an atom will be obeyed or satisfied even by adding or removing the electron. Electrons now add ಮಾಡಿದ್ರು charge of the nucleus remains same ಇರೋದ್ರಿಂದ ಇದರ neutrality ಅನ್ನೋದು satisfy ಆಗ್ತಾ ಇರುತ್ತೆ. ಅವಾಗ ಏನಾಗುತ್ತೆ ionic compounds ಅಲ್ಲಿ ನಾವು ಡಿಸ್ಟೆನ್ಸ್ ತಗೋಬೇಕು ಅಂತ ionic distance ಅನ್ನ ಸೆಂಟರ್ ಆಫ್ ದಿ ನ್ಯೂಕ್ಲಿಯಸ್, ದಟ್ ಈಸ್ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದಿ ನ್ಯೂಕ್ಲಿಯಸ್ ಆಫ್ an ion. ಒಂದು ion ನ ನ್ಯೂಕ್ಲಿಯಸ್ ಇಂದ ಇಟ್ಟು ಎಲ್ಲಿವರೆಗೂ up to which the nucleus has influence in its electron cloud. ಈ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ಕ್ಲೌಡ್ ಎಲ್ಲಿವರೆಗೂ ಇನ್ಫ್ಲುಯೆನ್ಸ್ ಮಾಡ್ತಾ ಇರುತ್ತೋ ಅದನ್ನ ನಾವು ionic radius ಅಂತ ಕರೀತೀವಿ. Okay, for example, see example take the sodium atom. Its atom has atomic number is 11. So electronic configuration is 1s2, 2s2, 2p6 and 3s1. Okay, electronic configuration is 11, 1s2, 2s2, 2p6, 3s1. That is 8 plus 2 10 plus 1 11 electrons. Outermost shell is 1 8 shells is 1 2 3 3 shells K L M 3 shells. So nucleus ಇದರಲ್ಲಿ ಇರುತ್ತೆ protons neutrons equal ಆಗಿರುತ್ತೆ. 11 protons ಇರುತ್ತೆ, neutrons 11 ಇರುತ್ತೆ, equal ಆಗಿದೆ. Electrons ಎಷ್ಟು ಇರಬೇಕು? 11 ಇರಬೇಕು. So first shell, this is the K shell, L shell, M shell. K shell ಅಲ್ಲಿ ಎಷ್ಟು electrons ಇದೆ? 2 electrons. Right, assume this is 1 electron and 2 electrons, right? Now L shell is 6 plus 2 8 electrons. 1 2 3 4 5 6 7 8 electrons. Consider 8 electrons. 1 2 3 4 5 6 7 and 8 electrons. Now M shell is electrons is one electron. Right, take here 1 electron. This is in M shell. M shell is 1 electron. Now this is the atomic radii, sorry not atomic radii, ionic radii. From here to here, this is called ionic radii. Now the sodium is an atom, so that we call this is atomic radii, not ionic radii. When we are removing electrons from this one, you get ion. When we are adding electrons to this one, you get ion. ಅಂದ್ರೆ ಒಂದು ಆಟಮ್ಗೆ ನಾವು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನು ತೆಗೀಲಿ ಅಥವಾ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನು ಆಡ್ ಮಾಡಲಿ, ನಮ್ಗೆ ಏನು ಬರುತ್ತೆ? ಅಯಾನ್ ಬರುತ್ತೆ. ಇಲ್ಲಿ ಸೋಡಿಯಂ ಅಲ್ಲಿ ಔಟರ್ ಮೋಸ್ಟ್ ಶೆಲ್ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ? ಒಂದೇ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಇರೋದ್ರಿಂದ ಈಸಿಯಾಗಿ ತೆಗಿಬಹುದು ಆಡ್ ಮಾಡೋದಕ್ಕಿಂತ. ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ತೆಗೆದುಬಿಟ್ಟಿದೀವಿ ಅಂದ್ರೆ ಔಟರ್ ಮೋಸ್ಟ್ ಶೆಲ್ ಅಲ್ಲಿ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ ನೋಡಿ? 8 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ. 8 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದ್ರೆ ಔಟ್ಲೆಟ್ ಕಾನ್ಫಿಗರೇಷನ್ ಆಯ್ತು, ಸ್ಟೇಬಲ್ ಆಯ್ತು. Okay, so this ionic radii can be further classified into two types. One is a cationic radii and anionic radii, or radius in cations and radius in anions. Now take the first one, radius in cations. Radius in cations. Now take sodium. This is alkali element. The alkali elements are always basic in nature. They form easily cations. Alkali elements ಅಂದ್ರೆ S block elements ಬಂದಾಗ ನಮಗೆ ಸೋಡಿಯಂ, ಪೊಟ್ಯಾಷಿಯಂ, ಲಿಥಿಯಂ, ಸೀಸಿಯಂ ಇವೆಲ್ಲ ನೋಡಿರ್ತೀರಾ S block element ಅಲ್ಲಿ. ಆ S block ಗೆ ಬಂದಾಗ ಎಲ್ಲಾನು ಕ್ಯಾಟಯಾನಿಕ್ ನೇಚರ್ ಆಗಿ ಜಾಸ್ತಿ ಎಕ್ಸಿಬಿಟ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿ ಸೋಡಿಯಂ ನ ಅಟಾಮಿಕ್ ಸ್ಟ್ರಕ್ಚರ್ ಇದೆ. Now the outermost shell having only one electron. Therefore, by removing this electron, the inner shell having 8 electrons is stable. Okay, sometimes, not sometimes, always when we are removing outermost electrons completely, this shell also disappears. Outermost shell alli banta electrons ella ತೆಗೆದುಬಿಟ್ಟಿದೀವಿ ಅಂದ್ರೆ shell ಕೂಡ disappear ಆಗುತ್ತೆ. Now this sodium atomic radii, that is called as covalent radii, is 154 picometer. 154 picometer ಇರುತ್ತೆ. ಕೋವಲೆಂಟ್ ಅಂದ್ರೆ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಎಷ್ಟಿದೆ ಅಂದ್ರೆ this is called as 154 picometer. This is called as ionic radii, metallic radii, or called as atomic radii. Atomic radii ಅಂತ ಕರೀತೀವಿ. So ion ಅಂದಾಗ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ರಿಮೂವ್ ಮಾಡಬೇಕು. See, now I am removing this electron. When I remove this electron, the outermost shell also disappears because there is no electrons. Electrons ಇಲ್ಲ ಅಂದ್ರೆ ಶೆಲ್ ಕೂಡ ಡಿಸಪಿಯರ್ ಆಗುತ್ತೆ. ಡಿಸಪಿಯರ್ ಆಗೋದ್ರಿಂದ ಸೈಜ್ ಏನಾಯ್ತು? ಕಡಿಮೆ ಆಯಿತು. ಯಾಕೆ ಸೈಜ್ ಕಡಿಮೆ ಆಯಿತು ಅಂದ್ರೆ ದಿ ಇಂಟರ್ನ್ಯೂಕ್ಲಿಯರ್ ಡಿಸ್ಟೆನ್ಸ್ ಆರ್ ದಿ ಎಫೆಕ್ಟಿವ್ ನ್ಯೂಕ್ಲಿಯರ್ ಚಾರ್ಜ್. ಎಫೆಕ್ಟಿವ್ ನ್ಯೂಕ್ಲಿಯರ್ ಚಾರ್ಜ್ ಮೀನ್ಸ್ ದಿ ನ್ಯೂಕ್ಲಿಯಸ್ is positively charged one, therefore it obstructs the negatively charged electrons towards itself. Nucleus ಅನ್ನೋದು ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇರೋದ್ರಿಂದ ಇದೇನಾಗುತ್ತೆ? ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ಕಡೆಗೆ ಹೇಳಿಕೊಂತಾ ಇರುತ್ತೆ. ನಾವು ಯಾವ ತರ ಗುರುತ್ವಾಕರ್ಷಣ ಬಲ ಅಂತ ಹೇಳ್ತೀವಿ, ಗ್ರಾವಿಟೇಷನಲ್ ಫೋರ್ಸ್ ಅಂತ ಹೇಳ್ತೀವೋ ಆ ರೀತಿ ಈ ನ್ಯೂಕ್ಲಿಯಸ್ ಅನ್ನೋದು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನ ಫುಲ್ ಮಾಡ್ಕೊಂತಾ ಇರ್ತಾರೆ. ಸೈಡ್ ಈ ತರ ಫುಲ್ ಮಾಡ್ಕೊಂತಾ ಇರುವಾಗ ಏನಾಯ್ತು? size of this atom or ion, that is ion, is decreases, so that the sodium, after removing one electron, it attains positive charge. One charge extra itu ಅಂದ್ರೆ ಪ್ಲಸ್ ಬರುತ್ತೆ. ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ತೆಗೆದುಕೊಂಡ್ರೆ ಪ್ಲಸ್ ಬರುತ್ತೆ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನು ಆಡ್ ಮಾಡ್ತಾ ಇದ್ರೆ ನೆಗೆಟಿವ್ ಆಗ್ತದೆ. Therefore the sodium ion, the atomic radius is 95 picometer, that is ionic radius. ಇವಾಗ ಏನಾಯ್ತು? ಇಷ್ಟು ಇಲ್ಲಿವರೆಗೂ ಇಲ್ಲಿತ್ತು, ಇಷ್ಟು 154 ಪಿಕೋಮೀಟರ್ ಇತ್ತು. ನಾವು ಇಲ್ಲಿಂದ ಇದ್ದು ಇಲ್ಲಿದೆ ಇಷ್ಟೇ, ಈ ಡಿಸ್ಟೆನ್ಸ್ ಇದೆಷ್ಟು ಬಂತು? 95 picometer. Okay, therefore remember, always very important, the cation radius is always less than the element ionic radius. ion ನ ರೇಡಿಯಸ್ ಗಿಂತ ಮೆಟಲ್ಸ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಅಂದ್ರೆ ಕ್ಯಾಟಯಾನ್ಸ್ ಕಡಿಮೆ ಇರುತ್ತೆ. ಕ್ಯಾಟಯಾನ್ಸ್ ಆಲ್ವೇಸ್ ಕಡಿಮೆ ಇರುತ್ತೆ, ಆನಯಾನ್ಸ್ ಜಾಸ್ತಿ ಇರ್ತಾರೆ. ಓಕೆ, which is less than, this is less than this one, which is less than metals. ionic sodium minus ಬರುತ್ತೆ, ನಾವು ಮೈನಸ್ ಜಾಸ್ತಿ ಎಕ್ಸಿಬಿಟ್ ಆಗೋದಿಲ್ಲ. ಯಾಕೆಂದ್ರೆ ಔಟರ್ಮೋಸ್ಟ್ ಶೆಲ್ ಅಲ್ಲಿ ಒಂದೇ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಇರುತ್ತೆ, ತೆಗೆದುಬಿಡಬಹುದು. ಈ ಶೆಲ್ ಅಲ್ಲಿ ಒಂದೇ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಇರೋದನ್ನ ತೆಗೆದುಬಿಡಬಹುದು, ಇನ್ನೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆಡ್ ಮಾಡೋದಕ್ಕಿಂತ ಒಂದ್ ವೇಳೆ ಆಡ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅವಾಗ ಏನಾಗುತ್ತೆ? ಸೋಡಿಯಂ ಮೈನಸ್ ಆಗುತ್ತೆ. ಸೋಡಿಯಂ ಮೈನಸ್ ಜಾಸ್ತಿ ಎಕ್ಸಿಬಿಟ್ ಆಗೋದಿಲ್ಲ. This is the cationic radii. Okay, the cationic radii is always less than anionic radii. Now take second one, anionic radii. Anionic radius. So the anionic radius is always higher than cationic radii. For example, For example, ionic radium, take oxygen. Example, take oxygen. Its atomic number is how much? 8. The electronic configuration is 1s2, 2s1, 2p4. Right? This is the outermost shell containing 4 plus 2, 6 electron. 6 electrons ಇದೆ. octet configuration ಆಗಬೇಕು ಅಂದ್ರೆ 2 electrons add ಮಾಡಬಹುದು. 8 electrons ಅಲ್ಲಿ ಸಾರಿ ಇಲ್ಲಿ 6 electrons ಅನ್ನು ತೆಗೆಯೋದಕ್ಕಿಂತ 2 electrons add ಮಾಡೋದು ಈಸಿ ಅಲ್ವಾ? So it is easy to add 2 electrons rather than to remove 6 electrons. Therefore, now this is K shell, this is L shell. K shell containing 2 electrons, already there is 2. And L shell containing 2 plus 4, 6 electrons. So remove 2 electrons. 2 electrons are ತೆಗೆದುಬಿಡಿ. Oxygen ಬರಿಬೇಕು ಅಂದ್ರೆ ಏನು ಮಾಡ್ತೀವಿ? 2 electrons ತೆಗಿಬೇಕು. So out of 8 I am removing 2 electrons. 2 electrons are ತೆಗೆದುಬಿಡ್ತಾ ಇದೆ. So yesterday 1, 2, 3, 4, 5, 6 electrons ಇದೆ. Now when we are adding extra 2 electrons to the p orbital, p ಅಲ್ಲಿ ಎಷ್ಟು subscriptions ಇರುತ್ತೆ? 3 subscriptions. 1, 2, 3. How many electrons are there? 4. 1, 2, 3, 4. 4 electrons is there. Now by adding 2 electrons here occupies. ಅಂದ್ರೆ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ? 1s2, 2s2, 2p, 6 ಆಯ್ತು. 6 ಆಯ್ತಲ್ಲ. ಸೊ 2 electrons add ಮಾಡಿದಾಗ ಆಕ್ಸಿಜನ್ 8 ಇರೋದು ಅಟಾಮಿಕ್ ನಂಬರ್ 10 ಆಗುತ್ತೆ. That is written as 2 minus. ಅಂದ್ರೆ 2 electrons add ಮಾಡ್ತಾ ಇದೀವಿ, ಅವು 2 minus ಆಯ್ತು. ಇಲ್ಲಿ ಒಂದು electron ತೆಗೆದ್ರೆ Na plus ಆಯ್ತು. ಅದೇ ರೀತಿ 2 electrons add ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ಆಕ್ಸಿಜನ್ 2 minus ಆಯ್ತು. Now 2 electrons ಜಾಸ್ತಿ add ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ಏನಾಯ್ತು? ಎಕ್ಸ್ಟ್ರಾ 2 electrons ಬಂತು. ಓಕೆ, 2 electrons ಬಂದಾಗ now the attraction force between the nucleus and the electrons is decreases because the repulsion between the electrons of one orbital and the electrons of another orbital is increases. ಏನಾಗುತ್ತೆ? ನ್ಯೂಕ್ಲಿಯಸ್ ಮತ್ತೆ ಎಲೆಕ್ಟ್ರಾನ್ ಗೆ ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸ್ ಇರುತ್ತೆ, ಎಫೆಕ್ಟಿವ್ ನ್ಯೂಕ್ಲಿಯರ್ ಚಾರ್ಜ್ ಇರುತ್ತೆ. ಆದ್ರೂ ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆಡ್ ಮಾಡ್ತಿರೋದ್ರಿಂದ ಔಟರ್ ಮೋಸ್ಟ್ ಶೆಲ್ ಗೆ ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎರಡು ಕಡೆನೇ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ತರ ಇರೋದು. ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಗೆ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇರುತ್ತೆ. ಎರಡು ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ? ರಿಪಲ್ ಆಗುತ್ತೆ. ಅದೇ ಆಪೋಸಿಟ್ ಚಾರ್ಜ್ ಇದ್ರೆ ಅಟ್ರಾಕ್ಟ್ ಆಗ್ತಾ ಇರುತ್ತೆ. Therefore, the internuclear repulsion between the two electrons is increases. Therefore, the size of an atom is increases. Atom size increase ಆಗ್ತಾ ಇರುತ್ತೆ. Hence, the atomic radii of an oxygen is 73 picometer. Oxygen 73 picometer ಇರುತ್ತೆ. ಆಕ್ಸಿಜನ್ ಅಯಾನ್ ಜಾಸ್ತಿ ಮಾಡಿದ್ಮೇಲೆ increases 140 picometer. 140 picometer ಆಗುತ್ತೆ. ಅಂದ್ರೆ ಇಷ್ಟಿಂದ ಇಷ್ಟು ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. 2 ಎಲೆಕ್ಟ್ರಾನ್ ಆಡ್ ಮಾಡಿದ ತಕ್ಷಣ ನಾವು 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದ್ದಾಗ ಇಷ್ಟೇ ಇರುತ್ತೆ. 2 ಎಲೆಕ್ಟ್ರಾನ್ ಆಡ್ ಮಾಡಿದ ತಕ್ಷಣ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಈ ಆರ್ಬಿಟ್ ನ ಸೈಜ್ ಸ್ವಲ್ಪ ದೊಡ್ಡದಾಗಿ ತರ ಆಗುತ್ತೆ, ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಅರ್ಥ ಆಯ್ತಲ್ಲ? ಸೊ ದಿಸ್ ಇಸ್ ದಿ ionic radius. Hence the ionic radii O2 minus is higher than the cationic radii like Na+. These two have the same electrons. So O2 minus ಅಲ್ಲಿ ಎಷ್ಟು electrons ಇದೆ ನೋಡಿ? 1, that is 2 plus 2, 4 plus 6 ಎಷ್ಟಾಯ್ತು? 10 electrons ಆಯ್ತು. ಅದೇ Na plus ಅಲ್ಲಿ ನೋಡಿ ಎಷ್ಟು electrons ಇದೆ? Na plus ಅಲ್ಲಿ ಎಷ್ಟಿದೆ? 2 2 2 ಸಾರಿ 2 plus 2 4 plus 6 10 plus 1 11 ಇದೆ ಸೋಡಿಯಂ ಅಲ್ಲಿ. ಸೋಡಿಯಂ ಪ್ಲಸ್ ಅಂತ ಹೇಳ್ತಿದ್ದಾಗ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ರಿಮೂವ್ ಮಾಡಬೇಕು. ರಿಮೂವ್ ಮಾಡಿದಾಗ ಎಷ್ಟಾಯ್ತು? 6 plus 4 10. ಸೊ 7 ರಲ್ಲಿ ಎಷ್ಟಾಯ್ತು? 10 ಇದೆ. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ಸೊ ionic radii is always higher than the cationic radii. Cationic radii ಯಾವಾಗ ಕಡಿಮೆ ಇರುತ್ತೆ? ಇಲ್ಲಿ ನೋಡಿ cation Na+ ಎಷ್ಟಿದೆ? 95 picometer. ಅದೇ ionic ನೋಡಿ oxygen 2 minus ಎಷ್ಟಿದೆ? 140 picometer. 140 and 95. There is a lot of difference. Hence the ionic radii is always higher than that of the cationic radii due to removing of electrons. Electrons ತೆಗಿತಾ ಇದೀವಿ ಅಂದ್ರೆ ionic radii ಕಡಿಮೆ ಆಗುತ್ತೆ. electrons ಆಡ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ionic radii ಜಾಸ್ತಿ ಆಗ್ತಾ ಇರುತ್ತೆ. So remember, ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್, 1 ಮಾರ್ಕ್ಸ್ ಗೆ ಕೇಳ್ತಾರೆ. So here the radius concept is completed.